And hello, welcome YouTube. So this is the next video, in the sense that yes, we're going to look into the nitty-gritty details of the pipe class now. So first thing first, I'm just going to git merge, squash, feature, pipes and valves. Okay, so there are some merge conflicts with the source code exploration and yeah, source code exploration tech, source code exploration PDF. Okay, so we'll probably have to look at some things. I will, of course, yeah, you see how many files I have put in here. So the thing is, I'll need to do some things with this merge commit issues, and then I'll add them. I will do this not on screen. I'll come back after I'm done. So yes, more or less I merged everything. So now the thing is, let's jump straight into the classes that I've added. Okay, so this will be in spiceSharpFluidFLowSolver libraries, and there are lots of things here like pipes and valves. Let's go to pipes and valves, and this is where you have some of the libraries here. So where do you start? There are lots of things I've kind of added. So I'll show you what I did with the class templating first. Okay, spiceSharpFluidFLowSolver libraries, go to pipes and valves, and then I'll go to the pipes. Okay, this is where I started, where I have a custom resistor. So look at the MockPipe custom resistor, and I will just use yeah, this one is another thing. I'll just vim in this directory. Okay, so let's open up a few things. The MockPipe custom resistor, which I will want to put in number 4. Okay, and open the biasing behavior. Okay, and I'll put tab new, unit tree. Okay, set number, set relative number, and the last one will be biasing behavior. Okay, do I have biasing behavior? I don't have it open. Okay, so let's GT, go to tab, and the base parameters, which I think should be, let me do this. I'll open biasing parameters here, and I'll open base parameters in the previous one. Go down, I'll do ls here, and I'll do base parameters, so that's b6, buffer number 6. Okay, so base parameters is very simple. Okay, so here's where I changed most of the things. Now the base parameters is more or less the same, but you can see that the namespace for the MockPipe custom resistor. So this is a custom resistor, but I just changed the class name to MockPipe. Okay, because it's supposed to be the standard template for which I model all the pipes. So this will be under the namespace SpiceSharp components. It will use the namespace SpiceSharp parameter sets, SpiceSharp simulations, SpiceSharp behaviors. No change there. Okay. The other namespace I use is SpiceSharp components, MockPipe custom resistors. So MockPipe custom resistors is the class that holds these base parameters. Okay, the base parameters is over here, and also the biasing behavior class. Okay, this biasing behavior class. All of this is actually under the SpiceSharp components MockPipe custom resistor namespace. Okay, so this one is in the MockPipe custom resistor behaviors, or custom resistor behavior namespace. This one is also under there. This base parameters, they are also there, and this one is there also. Well, what's the difference? Okay, so let me give a tab. I'll give a new tab. Okay, then I will just have a terminal open. I'll have a nerd tree open, and maybe I'll just exit this, and I'll just do ranger. Okay, so So this one allows for very quick browsing of files, very useful. So I'll go to the SpiceSharp and I want to show you what's the difference between them. Okay, so we go to SpiceSharp test. We go to this place called, what am I looking for? I'm looking for examples, and we'll do the custom resistor one. Okay, so now you'll be able to quickly see what's the difference. You can see in BaseParameters.cs, I have generated, this thing is actually a generated parameter, and I have this parameter name A and parameter name B. Now, the moment I see this generated parameters, it kind of scares me a bit, because you know, it's all this extra complexity that I may or may not actually want to use or get. So that sort of concerns me. Why is there this extra generated parameters there? Are we using auto-generated code for this? And then this parameter name A, parameter name B. Okay, I'm pretty sure there are standard things in C#. Okay, but again, I want to adhere by the keep the KISS principle as far as possible. Okay, so I'm taking all of these things out until such time I find that, alright, there is a real reason to put this in, and there's a real benefit to put this in. Otherwise, I don't want to put this in because it makes the code, you know, excessively complex. Okay, biasing behavior is more or less the same. Nonlinear resistor is more or less the same. And non-linear resistor test is, well, just not there, because this is actually an N-unit test. I opted to use the X-unit test to test it. Okay, so let me go up and let me show you, yeah. So you see that this part, parameter sets, over here in the base parameter class, I removed all the generated parameters and I just left the thing public partial class base parameters there. Okay, the parameter set will be called BaseParameters. Okay, and what the main thing I want to test for this is to make sure that when I make all these changes and I put the MockPipe custom resistor and I put this custom resistor, I put this nonlinear resistor. Okay, where's the nonlinear? Oopsie. Let me quick all. Yeah, I opened Vim within Vim, so there's a Vim. Oh man, too much Vim. Okay, yeah. So I opened this SpiceSharp nonlinear resistor.cs. Okay, nonlinear resistor.cs. This is a nonlinear resistor component. It's actually placed inside one of these tests. So the test is to literally just make a new circuit, as you can see here. Okay, the circuit will have a voltage source and a nonlinear resistor. It sets the parameter A to this value 2 times 10 to the 3, sets the parameter B to 0.5. Okay, so it uses a set parameter method, which I don't necessarily favor. Okay, because again, extra complexity. I do not want this extra complexity. Okay, so it makes a new DC simulation. So this DC simulation object is the type DC or the type DC classes. The DC class is being used, okay, direct current class. So what it will do is it will change the voltage source V1. So it changed the voltage source V1 from -2 volts to 2 volts in 1 times 10 to the -2 intervals. Okay, so this is the object is declared. Okay, this is the post-processing bit, and then this DC will use the run method on the circuit, which is this circuit object, which is the I-entity collection. Okay, the entities here are the voltage source and the nonlinear resistor. Of course, they are components, but they ultimately inherit from entities. Then after I run the circuit, then you will have this current export destroy, which I think is like dispose. I'm not really sure, but doesn't matter. The main idea of the test is if I swap this nonlinear resistor, I swap it in for the I swap it in for what do you call that? I swap it in for, yes, my pipe component class. Okay, my MockPipe custom resistor class. If I swap it in, then the results should be the same. I should get the same voltage results and all of that. So how did I do it? So I'll open a new tab again. I'll maybe have Ranger. I'll open a terminal. I'll open nerd tree, and I'll close this text edit. Okay, quit. Yeah. So open Ranger again, and then what I'll do is I'll go to the tests. Okay, my own custom tests. So FluidFLowSolver will have its tests, and yes, I'll have the custom resistor here. I copied and pasted the custom resistor class here just for reference. Okay, but most of the tests will be in here. Not the unit test CS project, but under the, let's see, where did I place it? Math test, yes, pipe and valve unit test. Okay, so this is the, oh, well, let me quit again, too much vim. Pipe and valve unit tests. Let's see, yeah, I kind of want to open this up, but I don't want to open up another instance of Vim. So let me just quit. I will not use Ranger. Maybe I'll use nerd tree to exit this. Okay, let me tap new, nerd tree. Yeah, I'll go up. I'll use nerd tree to open it up rather than this, what do you call that? Yeah, I use nerd tree rather than Ranger to open it up. Ranger is very good for previewing files. So where do I go? I'll go to tests. I'll go to pipes and valves, and I'll open up the test.cs file. I will v-split, vertical split everything. I'll put a terminal here. I'll quit this. .NET watch tests. Put logger. Console verbosity equals detailed. Okay, I'll just run this. Oh, .NET watch test, not tests. Oh, I'm in the wrong folder. This is a little bit annoying, but okay. Let's go to tests. And I'll repeat the same command. Yeah, I should have used Control I, but never mind, whatever. Okay. So again, I have a lot of things here. Just ignore this constructor here. This is just to help me print outputs. The most important is that yes, I have tested this here. Okay, I have a MockPipe resistor which I should auto indent. I want to auto indent it. Yeah. So the MockPipe custom resistor is something I make the class here. Okay, I can skip this test, or I can run this test for you to see. So this is a fact test using XUnit, and what do? I declare the MockPipe here, and I actually place it into the circuit over here, and then I do the run circuit and export destroy. It will produce the same outputs. Okay, so you see all these outputs are the same. They do a voltage sweep, which makes it very difficult to see what kind of outputs there are. You can see there's so many outputs here. So yeah, while this shows that the thing actually works, I kind of don't want to use this as a comparison test between this MockPipe custom resistor and the nonlinear resistor. Okay, the nonlinear resistor. Okay, and the other thing is that you see that over here I actually declared the nonlinear resistor object as NLR. I do it outside. I did it outside the circuit over here, so that I just put an NLR here. Okay. So the reason why I do it like that is so that I don't need to use that SetParameters method that I had over here. See this SetParameter method? SetParameter method only works with that. Only works with this code. Okay, SetParameter method only works if you have this generated parameter, and then I need to attach the text of parameter A name A and B down there. Okay, try to keep things as simple as possible. So the parameters of the resistor here are A and B. I might use this base parameter class to store what the pipe length is, what the surface roughness is, so on and so forth. But I do not want to introduce extra complexity if it's not needed. So if I were to not use this parameter name A and B here, and the generated parameters here, I will not be able, if I take out those tags, I will not be able to use this SetParameter method right here. So what I'll need to do is I'll actually need to manually access this base parameter class and change the values within there. Okay, I'll need to change the values within there, and yeah, that's the whole idea. Okay, so this is what I did. Okay, I wanted to test whether, you know, if I did it for the nonlinear resistor, does it work? Okay, so what I did is to access the parameter class within the nonlinear resistor, and I will access the class A. Okay, where does this parameter class come in? Yeah. So the parameter class comes in, I think, yeah, see, base parameters get equals to new base parameters. So this class is actually instantiated within this line right here. Okay, this class is instantiated within this line right here, and the base parameter class is object is actually based on this public partial class. Okay, base parameters, and it inherits from parameter set. Those things I'm not going to change. I'm just going to change the stuff within here. Okay, so I try not to touch as much as possible. And of course, all these generated parameter stuff, I want to take it out to reduce the complexity. I may not have all the so-called 100% of the features and everything. It may not be the so-called proper way of doing it, but that's how I want to do it. Okay, keep it simple. Alright, so yeah, so both of these I actually I just run them, and for now I just put it as skip because I already tested that yes, this thing actually works. Okay, yes, this thing actually works. So what I needed to do to convince, okay, oh, this is an overload thing. Okay, that one I'll sort it out later. And this one is to check whether operating point experiments can be done. Operating point is basically steady state, but let's see. Yes. Okay, so we'll see the part that says sandbox print results. Sandbox. What is that? Sandbox print result. Okay, so it says here that the test passed, but there's literally nothing else that is put there. Okay, this is what it is. Okay, let's see whether I have any more sandbox print result. Okay, so this was me actually trying to print results, because I changed some of the property things here. But let's see what else. Yeah, I was trying to get a result out of here. I have not even done the printing of results. Okay, never mind. I just want to perform a quick test to show you. Okay. Okay, this is a test to see results for vanilla. Okay, the non-linear resistor. Okay, so I'm gonna copy and paste all of this. Okay, this is the reference, right? This is the reference. Okay, yank it up. Okay, and paste it here, CIW XX. When nonlinear resistor is run, okay, I will reference result. Okay, so this is the reference result. Okay, reference result. Okay, I can't. When run non-linear resistor, my goodness. Okay. Yeah, okay, so this is all the data that's coming out of there. I was just looking for the big bunch of data. Wow, where is this data coming from? Okay, hold on. Let me sort this out, and then I'll come back to you. Okay, so okay, let me do this. Okay, since this thing is actually printing out so much, I want to actually change the voltage here to maybe be from 1.8 to 2. Okay, so the voltage range, the voltage sweep will be from 1.8 to 2 in steps of 0.02 or 0.2. Okay, so I don't print out so much data. Okay, let's see what the data is being given. Okay. Test Churchill friction factor laminar. Okay, let me do a me.cout. Okay, this is a custom method, or rather this .cout non-linear resistor reference result semicolon. That means it's easier to check all this verbosity, all this, meaning to say too much messages, too much information. Okay. So I'm gonna search this. Yes, okay. Here we are. So I echoed this test first, and here was it. Okay, maybe I'll not do so much verbosity. So I'll just use .NET Watch test, and hopefully things will go well. Yes, yes, the nonlinear resistor reference result is this. It looks like this 8.1 times 10 to the minus 7 or something like that. Okay, so that is I think the current. Okay, I think that's the current. Alright, so 8.1 times 10 to the minus 7, if I put these parameters into the voltage. Okay, as of now I still don't know how to extract it out into a double yet. How to extract out the current, the export and the DC information into a double. I still got to figure that out. I'll probably leave that for a later video. So this is the nonlinear resistor part, and if I were to swap it out, right? I were to swap it out for, yeah, I'm probably just going to copy and paste the same thing here. I'm going to yank all of this 19 down. I'll paste it here. I will, instead of using the nonlinear resistor, I will actually use what will I use? I'll use the MockPipe. Okay, I'll use the MockPipe. Alright, I'll just copy and paste this here. Yank it up and I'll paste it here. Okay, this is the test for MockPipe. Okay, I'm going to use the same DC settings. I'll make the DC a new DC circuit, but with the same things. I'll call this circuit 2. Okay, I'll use the same voltage source, of course, and export simulation data. DC2 export simulation data. I'll just call it DC export 2, current export 2. Okay. I think 488 DC run. I'll use, instead of DC run, I say DC2 run. Okay, and all of this here I want to delete. Okay. Yeah, and I'm gonna make sure that the resistor and MockPipe parameters are more or less the same, and I want to make sure this MockPipe result is here. Yeah, so this MockPipe result is a -0. Did I connect all the nodes correctly? New voltage source V1C out. I'll put the MockPipe in there. Okay, so this thing isn't actually working the way I wanted. It looks like this reference result is 8.1 times 10 to the -7. MockPipe result is like at 0 volts. So I think what I'll try to do, I'm not sure if the bug is actually found in the way I construct my circuit, but I'm just going to delete everything here. I'm going to make a new fact test, and I'm going to copy and paste everything. And I'll say this is let's see. So this is the reference resistor, and then this is the MockPipe. Okay, the MockPipe. Okay. Change this to MockPipe result. Okay, now I'll do everything in here. I'll cut this, paste this here, take out the nonlinear resistor. Okay, substitute it for the MockPipe. And let's see whether it's the same or is it different. It says that the MockPipe is already declared in this scope. 501. Oh. Let's see. Ah, yes. So yeah, apparently doing this actually works. You see that the nonlinear resistor reference result is 8.1 times 10 to the -7. The MockPipe result is also 8.1 times 10 to the -7. So I think the lazy copy and paste actually did something, so, but doesn't matter. Okay, so what I see here is the MockPipe nonlinear resistor reference result. If I sweep the voltage from 1.8 to 2.0, it's 8.1 times 10 to the -7. I don't know what, I think that's a current. And the MockPipe result here, when I sweep again from 1.8 to 2, okay, this produces the same number for me. Okay, I need a way of extracting the number. I don't exactly know how to do it, except maybe using some global variable or something like that. Yeah, which is something I'll possibly do for this. But yeah, other than that, yeah, I don't see anything else there. Okay, I'll probably have to learn how to use events as well to export data. But main point of this is that yes, this code, these two lines of code actually present you the same thing. And I'm going to try writing. Yeah, I'm going to try writing the documentation, but I hope this actually shows you that the MockPipe template which I use for my pipes and the custom resistor, well, I changed a few things like changing out the parameter and the parameter generation thingy. Here, well, I took out this generated parameter thingy. It still pretty much does the same thing. Okay, so that's what I did, and now I'll probably just skip this test. Okay, I need to use capital S. Okay. And then I'll need to put in a string. Equals to 8.1 e minus 7. Okay, so this is how you skip fact tests, if you didn't know, but I'm pretty sure you do. You're pretty, yeah. Okay, so I'll skip both these tests, but yes, this actually shows that the MockPipe and the nonlinear resistor, while I changed the code here and there, they pretty much give the same result when I put them into exactly the same tests. Okay, so that's all I have for the time being. I'm going to maybe take a break and then maybe write some documentation, and I'll be off again. Yeah, maybe see you in another video. Okay, so next time we'll talk about other stuff as well. See you.